Yes, welcome back. Are all back, or are we missing some?
Yeah. Niels, could you drop into that run 1 for 1 second? Just want to look over something.
Yeah.
Thank you.
So this one?
Yeah, the first one I think was the milk one. Yeah.
Yeah. Yep.
Perfect. And just one thing, Niels, I'm just having trouble with. I have mine as flow rate as liters per second. To change that to liters per hour.
Yes.
Is that in the settings? Is it? Or...
You can do it. You can do it two ways. You can you can right click here. Sorry,
okay.
here. When you stand in the field, you can right click and change units.
Okay.
And then change it to something. But I would definitely recommend you to change to PED units. Then it should come in liter per hour. If you change here in unit systems, try to do
units. That. Oh, okay. Perfect. Yeah, I have that there. Thank you very much.
Okay. But it is sometimes that the customer comes with the flow rate in cubic meter. So yeah, but you can then put yourself in the field and then right click and then change to cubic meter per hour as an example.
Perfect.
So the functions are in there. Yes, I changed my mind a little bit because this item or file here we are playing around with here is just a show file. So it will not be related to the first assignment which I'm going to send to you. I believe that item number 2 or even a complete new ASK file will be the one we will work in when we start doing all the assignments. This first part of the training is showing you how to navigate, how to set up a duty, etc. It's not related to a specific inquiry. So I will just call it test. Okay. See, this was one item with 2 duties. Then it could be that your customer, he wants a 3rd duty or 4th or 5th or whatever duty shown on this calculation, either shown on the calculation or designed for. So adding duties up here, you saw I did that before, but it's up on adding duties. Then you have different possibilities. When I did the water, I selected original. You can also do an alternative, which could be completely different from what the heat exchanger is actually running with, and you can that could be done just for you to see if something works in it. But normal way is to show the customer what is this a heat exchanger actually capable of doing, obviously. So if I know that the next duty I'm going to do is also milk cooling, I take this one from current as original. Then it makes a copy of this one up here. Then I rename it so I know the differences. Then that could be 5,000 liter. So he wants a variable capacity of this one. And then I change to 5,000 liter here. Please let me know if it's going too fast, too slow, or I need to know whether it's in the right tempo.
It's good.
Okay. This was setting up the duty. I'm not going to do further duties here. We can always play with that later on. For now, we just started simple. Then you have two possibilities, because now we have the duty done. This is what we want the heat exchanger to do. So now we're gonna select the heat exchanger to do the job. There's two ways of doing that. There's either pressing this one. If you do that, you automatically jumps into a dialog called How to Select Cheapest. That one is fine. That one is fine if we're talking about water heat exchangers. Then it will give you a reasonable design based on price. When it's a sanitary application, it's a bit different, because in sanitary applications, we are more limited in relations to what we can allow of different things. As an example, when we are dealing with fatty products, product containing fats, we say maximum 1.5 up to 2.5 meter per second in the fitting and in the port, in order not to disturb the fat globules of the product if we go higher in velocity. But the program is designed for industrial, so it actually allows you to go up to 6 meters per second. So that's why I'm saying that auto selection cheapest is not the best to use when doing food designs. You can, of course, use it, and I will show you how it's functioning, how it's working. But I always make the design myself based on some selections I make outside ASK. I don't let the program do it for me. The other way I'm talking about, the way of doing it manually, is then don't press this one, but press solution and then add solution default. Then you manually add a solution. But let's try so I can show you how auto selection cheapest works. Let's try that. It is so. The duty you're standing on will be the duty that the program tries to select a heat exchanger for you. So sometimes you get inquiries where there are maybe 10 different duties that it has to operate with. And for a fact, when you look at it, you actually don't know which one is the most difficult one. So try to select what you think is the most difficult one as number one, and then let it design from that. And then afterwards, when you have done all the other duties, you might have to do some adjustments in numbers of plate passes, maybe even the size of heat exchanger, etc. But here it is clear that the 10,000 liters is the most difficult of these duties. Let me have a look at the HVAC duty. It is. So now I'm pressing the green arrow again. Then it jumps into this one, which is auto selection. You can select from list price, heat transfer area, and target lead time. Do not use target lead time. I actually don't know if there's anyone. There's no one. I will take list price to the top. Do not select from target lead time, select it from the price. Target lead times in ASK are not correct. Sadly to say, they are from when we had the factory in Denmark. And that time we were able to produce relatively fast and a lot faster than they can do in Poland. So do not trust the target lead times. They are in there as guidelines. But if you want a firm lead time on a specific heat exchanger you have designed and quoted, you will have to go to customer service in Bydgoszcz and ask for a confirmation on the lead time, especially now where the supplier situation is not very good. Lack of steel on the market, lack of gaskets, there's everything. It's not that good. So in these days, I would recommend you to ask for the lead time to have a confirmation on it. Before starting this one, we have to take some decisions or make some choices. Down here, we can set the design temperature and design pressure. If it's a milk intake cooler, I'm not sure that they want a 10 bar. I would suspect that a 6 bar frame will be good enough. So if we put in 6, then I'm not sure what your profile gives you, because the next thing I'm going to do is I'm going to press design filters. Have your profile selected any filters? I'm asking Pasilac and Axflow.
I don't have any filters selected.
Okay. Then when doing auto selection and even doing quotes as a general, I would recommend you always to have just a small portion of filter, or else the program goes through every variant of heat exchanger types plus production sites. And that makes the program a lot slower, obviously, that it has to go through the whole database. So what I always do is I press this small plus, and then I get the plants. And I select Poland, Bydgoszcz. And then I select it here and press the green one here. Then I have Poland. And Tanya, you could select Shidu.
Okay.
Then now I will only get what they produce in Bydgoszcz. Then the next thing is, I don't know how many different product ranges you have here, but obviously I can do spares and obsolete parts and everything. But always select this one. If you have several options, just select the standard basic variants. Now this is your filter. Now it will limit the selection possibilities a lot. First thing is you don't get confused about all the possibilities you have. Next thing is that the program will work faster. Save. You could say save, or you could say apply. It would be the same function. Have everyone done that?
Yes.
Yes.
Good. Then here we have two functions, or three, or more. Here you can actually fill in from the beginning that you want the selections to come up with minimum 10% excess area, as an example. And then the next one here is important when we are talking about food. I don't know if you remember, but last time I said, when doing designs or arrangement for food heat exchangers, we do not allow mixed channels because that is related to the CIP and the efficiency of a CIP. We either have thermo hard all 30-30, or we have thermal mix 60-30, 60-30, 60-30, or we have thermal short 60-60. We do not allow different blocks with a combination of these three. So since this is a milk cooler that we are quoting for, you might as well put a mark in no mixed channels. If it were for a specific customer who requested only all 4 connections on head side, you could put a mark here in single pass only. We will not do that. We will try to do the cheapest possible heat exchanger on this one. So if everyone have put in 10% and no mixed channels and list price and set up the filter, I will then press start. Let's see what it comes up with. And if we get the same results. You see here, it's checking 637 solutions. And if I had if I didn't have any filter at all, it would have been a lot bigger. Okay, see, we now use the auto selection cheapest for a food application. And what do the program gives us? Pretty sure that it gives us painted frames because it's looking on price. Down here we can have a look at what it's selected. These one are small HVAC heat exchangers. They are called Myras. This one, Orion is a food heat exchanger, could be a food heat exchanger. This one is a industrial heat exchanger. N35 is definitely can be a sanitary heat exchanger depending on the frame you select. But the thing is, it did a selection on price, and therefore it gives us the cheapest possible. We could have done something else. We could have said, on top of these two we selected in the filter, we could have said configured PHEs and frame groups, sanitary frames only. I'm now showing you this filter, even though I never use it. Yes, I use Poland and standard, but I never start going down in the filter and sort out stuff because I want the whole palette to select from. But this could be helpful for you in the future when you're using, at least when you're using the auto selection cheapest. The reason why I'm saying this is at some point you have might made some choices in the filter, and then you have quoted it, and then the customer comes back and says, no, I want a painted frame, and then you open your ASK file, and then you're not able to select a painted frame because your filter is set up to only sanitary, And you can't find out, why can't I select a painted one? Yeah, but it's because your filter. Then you will contact me and say, this ASK file, I can't select this and this and this. And then it's because of your filter. So what I'm saying here is try to limit your usage of the filter until you are very familiar with it. You can also use it, up to you, but I'm just saying I never use it. But for beginners, of course, it's a good idea. Now I've selected sanitary frame, so now I will start again and see what happens. Now it's only looking at 137 possibilities. And funny enough, I noticed when we did when we got the sanitary ones, sorry, the painted versions, we got an N35. But suddenly it's not selecting an N35, which I know will be cheaper than the ones that it has selected here. So that's why I'm saying when doing food sanitary calculations, be careful using auto selection cheapest. Is that clear?
Yes.
Yeah.
Yeah. Good. If you decide, I will just finish this telling about this auto selection cheapest. If you decide, okay, we say this is the one we want to have a look at. Since this was the cheapest one, we will have a look at this one. So you just put your cursor on it and select a solution. Then note that it has selected this one in the quotation tree. Then you can go in and have a look at it. It selected a Quasar 030 with an RKS 10 frame, meaning it did select a sanitary frame. Okay, we will not look further into this one. Actually, I will delete it. So I will show you the other way of selecting a heat exchanger. Delete. Okay, to my duty. And I go to solution, add solution, default. Note down here. Now my filter is emptied again, because now I'm doing a complete new one. Remember I said 6 bar. Apply. Design filters, I will take Poland. Standard basic. Daniel, your design isn't your profile set up just to have Bytgos and standard basic, or how is it with the AskFlow profiles?
I believe that's right.
Yeah, okay. So you actually don't have to do this. It's already set for you, right?
Yeah.
Yeah. Now at least it changed to Butgers. Now, of course, you are in you are in doubt which heat exchanger to select for 10,000 liter milk cooling. And the way I decide that is, the first thing I look at is velocity, fitting and port velocity, mainly fitting velocity. Okay, I think about 10,000 liter and I need around 1.5 meter per second, between 1.5 up to 2.5 meter per second. That is where I'm gonna start looking for a heat exchanger. And therefore, I don't know if you have looked at it, but I'm now opening this PHE new web design tool, which I sent to you. So we all have a look at that now. What you do in this program, you enter in the flow rate and then enter. And I will put in the 10,000 liter. Then this will give you a guideline. Because if I say I need around 1.5 to 2.5 or whatever meter per second on a milk intake cooler, I can easily see, okay, a T4 is way too small. It will give me way too much velocity in the fittings. Okay, then I look at the next time. These are only the sanitary heat exchangers. Remember that, where you can get a sanitary frame and sanitary connections. H17 could work with a 2-inch connection. N35 will work. And then if I go into the bigger ones, yeah, the smallest size of connections is 2.5 inch. So maybe that's overkill. That's why I said that the Q30 that the program selected for us, actually it's here, might be overkill because the smallest possible connection on that one is 2.5 inch. That's what you can use this program for. Another thing you can use it for is that it gives you all the information actually about the plate itself. It gives you a guidelines to the capacities in it, depending on size of connection you select. It gives you the area. It gives you port velocities with this given flow. It gives you the size of the port and it gives you the plate gap. On top of that, it gives you a guidelines to CIP. Depending whether you select 30-30, 60-30 or 60-60. Then it gives you the guideline to how many channels you should have in each pass. If I, for example, say, and that is calculated from the basis that your CIP pump is pumping the same as your product pump. Put in 15,000. It says, yeah, then I should have around 20 channels. We haven't been talking about CIP yet, but we will be doing that. I also sent you a presentation regarding CIP, and we will go a lot more detail into that when we start designing a heat exchanger. But the way I'm working is that I look at the flow rate and say, okay, 10,000 liter, that could run in a 2-inch connection. Okay, then I have two possibilities. Then I have H17 or N35 or bigger heat exchanger to go from. Definitely T4 is out of the way. So that's my first approach when selecting something. Did that make sense?
Yeah.
Good. Okay, we found out that N35 and H17 could be a choice. So that's what I'm going to start with. Starting with a H17. See, the program from the beginning selects the smallest connection possible on this particular frame. Please note that it took a 6 bar because we have entered in 6 bar in design pressure. If we have entered in 10 here, it would have been forced to take a 10 bar by automatically. But the first thing I do when designing is looking at connections. Obviously, we have way too small connections here. We have 17 meter and it says actually 8 meters, but that's because it's looking at water. So we for sure need to select bigger connections. There's 2 ways you can select connections. You can do it here in this picture, or you can do it up here in connection by stream. I tend to use this one up here because I think I have a better overview. So here you can put a mark and use same fitting for all connections in a stream. This is stream 1, that's the milk. Stream 2 is the water. We found out that 2-inch was a good size of connection. So I'd just, for example, I take a 50 millimeter DIN connection. And for the water, I will also take a 2, or I could go even higher because my flow rate is higher. But I will try with a 2-inch on water side as well. So now I have all 4 connections with 50 millimeter DIN connections. Just so you know it right here, you don't have to have exactly what I have on my desktop right now, because this is just a play around file. It's not an actual assignment. So if you can just change to some sort of 2-inch connections, it's okay. We don't have to compare prices or designs later on. I'm just showing you the functions in ASK right now. Then I say, okay, that was the first thing I did. I selected a heat exchanger where I could get the right size of connection. Next thing was that I changed the connection size. Note, all warnings went away. The next thing I'm doing, stepwise, is I go in and look on plates and gaskets. Remember I said 316 is the standard. We have 304 available for some types, but it's not something where we maintain the stock. So 316 is standard material. Then thicknesses and clip, par clip or easy clip gaskets, and thickness and gaskets. So see, the program came up with a solution over here. You can see that over here. With 1 of 19, 1 of 19, and with low pressure drops, but also with a minus in the heat transfer area. If you put a mark up here in autofill arrangement, it automatically autofill it and calculate a reasonable solution for you. You could also have done it differently. You could, if you don't want to use this one up here, note that when this one is marked, Sorry, just went a little bit. When this one up here, when you have a mark in this one, you're not able to change anything manually in the plate arrangement, set arrangement. So you have to remove the mark up here, and then you can play around with the arrangement. Now we have possibilities. There's also a third way of letting the program calculate. Note when we fill in, when we set the autofill arrangement, the program also changed the connections. That was not nice. So now we have to go back. Up here we have a 2-inch connection, so 50 millimeter. I will put a mark here. One other way to select the connections besides going down the menu here is to, if you, for example, select 50 millimeter up here in the first one, you can put yourself in the field and say Control C, and then go to the next open one, put yourself there and say Control V. Then it copies in the fittings. That is very useful when you have a multi-section with 20 connections on it. So you put yourself in it, say Control C, and then to the next open one and Control V. Okay. See, now this one is open for playing around. There is also another possibility, and that is using this one, auto arrangement. It should not change the connections. Let's try it. Here, again, you should put a mark in no mixed channels. And then we could say we want 5. What did we say? We say 10% X's when we did the auto selection. So let's try that. We say OK. Then it makes a solution with a lot of plates, but also with a lot of excess area. And suddenly we have too many plates to be in the frame. It can't locate a frame large enough for this amount of plates. You see, it's 59 plates and the frame can only have 57. Okay, so that was not a good way to do it. Further to that, I can see that, as far as I remember, it has some issues here. I can see with the fitting velocity. Again, the program has, sorry for that. Again, it has changed the connection sizes. What? Suddenly it's not able to change the connections. Sorry. Okay, what I looked at was the fitting velocity here, and it was way too high. Okay, so the best way is to go in here via set arrangement And then look at the guideline here. Arrangement guideline. That is based on your thermal job, and it's based on the pressure drops you entered in. So it will come up with a guideline so you fulfill these two requirements. So let's try. If it's a mixed combination, it recommends 2 of 14. If I change to 30, it says 1 of 30. What happens if we say 1 of 30? Anyone knows that? No, because I haven't taught you yet. But if we say 1 of 30, it will give us a huge CIP, because 30 channels will require 30 channels multiplied with 750 liter per plate channel. So that will give us an approx needed CIP flow on 23 cubic meter. So that's out of the way. So we will try this one. We have to force into 2 passes. 2 passes of 14 channels. So we try to follow the guideline. So in group, we will say 2 times 14. Use the tabulator in this dialog box as well. And then we will say 0, 0, 0. Okay. We definitely have area enough. We are around the pressure drop we specified. We could actually, because we have this much excess area, 32, we could play around with flow rates on ice water and maybe reduce the numbers of plates so we don't get too high a CIP flow rate. But we will not do that right now. Because we have some other functions we have to look at here in ASK, how they work and so on. Everyone follow until now?
Yeah.
Yep.
Okay. Let's say that you are doing a new inquiry for a particular customer, and you quoted a similar heat exchanger to another customer 1 month ago. Then you actually don't have to recreate it from bottom. You can drag it in from another quotation. So we can we can copy quotations, we can drag in items from other quotes, etc. I will just give an example of that right now, so you see how the function is working. I call it, or I use the add-in item, and I say from quotation. Then obviously I need to know the quotation number, or else it's impossible. So I will just try to drag in one from this item here. Sorry, from this quote here. For LI set search. Then I have it here. And then I say, okay. Then in this one, I did a lot of different items. And I also did, as far as I remember, 2 revisions. So what I will do is, okay, I know it's revision number 2, and it was a milk heater. I did that one, and I want to present that in this new quote to my other customer. So I just put myself on the item I want to drag into the new quote and say, okay. then suddenly it's here. Good function. That was copying item in from other quotes. It could also be that you are quoting something similar and you just have to do small adjustments to it. Then it's a good idea to drag it in from somewhere else, because you save yourself a lot of time. And then you just rename the headline of it and whatever. So that is one way. Another way is that you actually, let's say you have lots of items in it and you want to do a new quotation, which is again a copy of something similar done in the past. Then you simply go to the quotation and say new quotation from current. You open the one you know. You open the one you know you want to copy, and then you just say from current. Then it says, please confirm that you want to create a copy of this one. You cannot cancel this action after blah, blah. Okay, yes. Then it needs a quotation title, new quote. As an example, and then a reference date, delivery date. And again, this is one which we just playing in, so I'm calling it as it's a test quote. If it was a firm quote, don't put a mark in test quote. Then I get an exact copy of the one here. But let's say in this new one, I don't need item number 1. So I can delete that one. Then I just have item 2 in it. That was, I will just drag this one over here. I think that covers how to insert, copy, navigate in ASK. We will, of course, navigate a lot more in ASK when we start doing the assignments. But now we have covered most of this one. We have set up a single section duty. We have tried that. We have how to use system fluids, selecting from the system fluids. We have not looked at this counter current, co-current. We will look at this in a short while. This one we have missed. We will do that right away. I will take this one first. You see, there's a lot of things we have to cover, so I'm trying to do it as structured as I can remember by looking at the agenda. But sometimes I will jump backwards and forwards. There are so many functions, so many things we have to cover, so it's not always that easy. This heat exchanger here that we did, the first one, we can only see duty number 1. We have not asked the program to look at, can you do duty number 2? Can you do duty number 3? The way to have them shown on the calculation data sheet and to see whether they work perfectly is to add them as duties to this solution. You see right now, when you push the plus here in the tree, you can see it's only linked to run number 1. These two are not linked to the solution yet. But before doing that, I will try to optimize this design that I made here. Because I have 32% excess area, that's way too much. In theory, we can cool it down to around 3 degrees. So how can I reduce that? Yeah, one way is, of course, lowering the ice water flow, and that might make him happy in relations to how big a pump he has to purchase for his ice water. So then I go to the duty. Oh, sorry. Yeah. Then I go to the duty and see here, I see the duty, but if I change something here, I can't actually see the result of it right away. So what I do is down here, I have the technical result box. So what I do is I double click on this head bar on technical result. I double click, sorry. Then it jumps up here as a box which I can move around. Then I move it over here. Then I can make it bigger so I can see all the information in it. Then when I do some changes here on the duty, I will see them right away here when I recalculate the technical result. So now I will try to reduce the flow rate, the ice water. Then suddenly this one gets enabled, and then I press this one. Now we are down on 18%. We are underneath, we are on 0.7 bar, and we allowed 1 bar here. So actually now we are able to take some plates out of this heat exchanger. If we want to have around 10%, I would recommend to have that on a small milk cooler like this. I would have around 10%. So I will try to take out plates until I get around 10% and 1 bar over here on the water side. See, now we are on duty in the tree, so we have to go to the solution in the tree to make some changes. Set arrangement. Now it actually says 2 of 11. Okay, let's try that. One bar, 7% in excess. Yeah, it looks fine. We can get this one a little bit lower, plus we can get a little bit more excess area, and that is by doing a water wrap. If you look here now, the red one is the milk stream, and the green one is the water. If we do a water wrap, we will get the last plate here as a water plate. Then we wrap or we pack in the whole, all the milk into water channels, meaning that when the product leaves the heat exchanger, we can be more certain that we don't have too many temperature layers in the fluid leaving the heat exchanger. So if I do that, I see set arrangement. I say 1 of 11, 1 of 11, 1 of 12 channels on water side. Then I have 1 extra water channel on each side. I'm just underneath one bar and I have 9%. Perfect. We will keep it as this. Okay. Then I want to show you how to have several duties connected to this heat exchanger. What you do is you go to General Solution Data. I will just, if you double click on this one again, it will jump down to its original position. So I do that. Then it jumps down to original. See, here are the selected duties, and this is the one it's designed for, the 10,000 liter. And here, over here, we have available duties done. So if we want them to be shown on the calculation and want to design the heat exchanger accordingly, we can drag them over by pressing this green one, selecting them and pressing the green arrow. Or you could have selected all by using this one here. Save. If we then go to General Solution Design, now we have all the duties. 1, 1, 1, 2, 3. And you see the other duties are a lot easier, but they are also different in flow rates, etc. So now we can go in and play and adjust these duties. So, or we could leave them as they are, but there's no point in having 25 cubic meter cooling only 5,000 liters. It's half the amount that we had here before, and here we're using less. So what I would do is I would go to this 5,000 liter. Oops, sorry, yeah, there. Why did anything happen? Like that. Then I will double click on this one again. Then I will adjust my flow rate to maybe 10,000 liter. Maybe that's enough. Yes, it's still enough. We can actually go even further down when just cooling 5,000 liters. Okay, I will leave it here. Okay, this duty in the middle was just one I did for fun. So I actually don't want to show it on this calculation. I don't want to show the customer this one. I just did it for you to show how to input data on a HVAC duty. So what I do, I will remove it. I go to the heat exchanger. I go into General Solution Data. I double click on this one so it's not in the way. I click on the duty and I remove it. Plop, now it's gone. I can then choose to have it stay here. When I close the file, when I quote it and everything, I can let it stay, because let's say you know that this customer, he will probably come back and ask for this duty at a later stage, then you have it already. But you could also just delete it so it doesn't confuse you. As soon as the duty is in this position on General Solution Data, you can delete it. So you say save, and you go to duty, and then you can delete it. Then I would rename this one to duty 2. Like that. that was playing around with duties. Then I want to actually, Danielle, he had a situation with where someone, I don't know if it were you or yourself, Danielle, have made an alternative solution to what I already did here, maybe just to check price or whatever. But he wanted to quote. He wanted to quote the alternative or opposite the original. So I will show you that function, how that is working. I will just create a history here. Yeah, we want to quote to the customer, or we want to check what is the price difference between a stainless steel heat exchanger with this configuration compared to a painted one. So what we do is we put ourselves in the tree in my structure. We go to solution and we add a solution from current. Then it will make a precise copy of this one. Then I will try to change the frame to a painted one to see what pricing I then get. Okay, that was lower. Close to 4,000 euro less with a painted one. If you use the template, but I'm not sure if you do that, but if you use the quotation templates, which I've not shown you yet, which are in ASK, it will come up with this as a main solution on the quote and this one underneath as an alternative with the two different costs for it. But what we always recommend people to do when they have quoted a heat exchanger, maybe several alternatives, etc., and then in 2 months they get the order, we ask you all to clean up your ASK file so no one can get confused on all the different solutions hanging in your ASK file, because it can create confusions on which one is it you want us to start producing. So that is when we say cleaning up the ASK file. I will just show you. But another thing is the problem that Danielle had was that actually he want this one down here to be the main solution and the other one should be the alternative, as an example. The way of changing that is to go into solution data again. And then you see down here, this is alternative and it's called alternative here in solution tab. Then you change that to main. Now this one is main, and now you can delete this one when you clean up. Because you are not able to delete a main one, you can only delete alternative solutions. So this function is also here in general solution data, where you change from main to alternative. I will now clean the ASK file up because this is the one we are concentrating on. So I will clean it up, as I call it. Solution, delete. So now I just have this one visible. Now I come to something which is a little bit, I will not say difficult, but some people find it difficult. I want to, what we have done here is we have done a heat exchanger where we have, if we look at the plate diagram here, I will enlarge it. We have the milk flowing in hole number 4 and out in number 4, and we have the milk flowing from F3 to H3. That means that if you look in the front of the heat exchanger, your upper left hole is called 1, upper right is called 2, lower right is called 3, and lower left is called hole number 4. So in this case, the milk is flowing in the left side of the heat exchanger when it's flowing in H4. But the customer, we could say the customer has asked us to have the inlet in the right side of the heat exchanger. So we need to have the milk going from here into this position, and then the water has to go in this position. That can be done in here in the plate arrangement. I will close it down again so you see where it was. It was here, plate arrangement. And then you should press this one called stream positioner. Then we can make some changes. And no, we can't. This is on purpose. You see, all the possibilities we have here are disabled. Reason for that is that we have two duties hanging to the solution. We have both the 10,000 and the 5,000 liter. You can only change the stream schematic or position of streams if you just have one of the duties hanging to the solution. So in order to do the changes here, we need to go into general solution data, and we have to remove this duty for the time being. We move it over here. So now we only have this one linked to the solution. Then we go into plate arrangement. Sorry, we have to save before we would do that. We go into plate arrangement, press stream schematic, and now they are suddenly, we have some which are enabled. What I wanted was that I want the milk to flow in the right side of the heat exchanger instead of the left side. So what I do is I scroll over these positions or these small icons and see what happens if I press it. It's important to read the text here, or else you get confused. Here it says change flow inlet, change flow inlet on top and outlet on top. That was not what I wanted, because if I press this one, please note what happens. I've done it now. I say okay. Then it just changes it to the top of the heat exchanger. Stream positioner, I will change it to the bottom again. Now we are in the bottom. The same goes for this one, obviously. Then there's two more here. Then we can change the section head follower. That means it can change. So the inlet will be from the other end, from the follower instead of the head. If I press it here, it changed the inlet, if you see here, from follower side instead of head side. So now we have the milk inlet over here. But that was not what I wanted. I wanted to swap the two streams, shift them from left to right. So I go back to original, and then I take this one, change section far near. Then it changed. So now the milk is in port 2 or 3, and the water is in port 1 and 4. Now I have the milk in H3, F3, water F4, H4. This is relatively simple when it's a single section, but believe me, when we get into a multi-section, this can be a nightmare, but you get used to it. You get used to working around with it when you want to decide where to have your connection positioned. I might as well show you that while we are here. In here, in this plate arrangement, there's also a tab called Remarks. It's a very useful one because in here you can fill in whatever type of information you want to the customer to see, but maybe also the production in Bydgoszcz to see. So in here, for example, we could say that the, I will just make an example, the particle, hopefully there's no particle but in the milk, but it could be. This is particular for the customer, of course, because if you forget to mention this in your quote to make the conditions within you have designed the heat exchanger, you have stated it on the plate diagram, so he cannot walk away from it. You have shown it to him, so he's aware of. He should be aware of it if he reads the documents you sent to him. So that's what I use this for. This remark field. It could also be, if it's a special, if it's a painted one, it could be special paint something like that. That could also be. So I frequently use this remark field to put in information that I want the customer to see, but also the production in Bydgoszcz. And that is to be found on the plate arrangement and then remarks. Okay. Save. Now we have changed the stream schematic or stream positioner. Yeah, note, I didn't show you that, but I normally take it from here because then I can see the whole plate diagram, and then I use it, the stream positioner down here. But you can actually also select it from out here. But then you don't have the plate diagram and you can see the changes immediately. So I always use it from plate arrangement and then stream positioner. But still, we are only showing this one duty because we had to remove it in order to change the stream schematic. So we go back to general solution data, we mark the duty, and we move it over to the heat exchanger. Save. Are there anything that you didn't get in this this presentation? you see here, this is something we have to be aware of. The program has sorry my language, has changed the connections when we did the swap upwards and downwards and all that we did in the streams plate arrangement. So we just have to go back and make sure we have the right connections still. You see, it took a 25 millimeter at the inlet. So this is important information that I'm giving you now. When you are close to being finished and happy with a design you have made, please double check that ASK have kept the solutions you intended to select. Because when you start playing around here in the stream schematic, or if you try to change something in requirements, it has a tendency to change at least the connections. So before quoting your heat exchanger, double check everything you have selected. Okay? This is important. I will change the connections again. Save. In theory, we are finished with this solution here. Of course, we could optimize some more on it or play a little bit around with it. But in principle, we are finished with this 6-bar H17 that we have selected here. But we are missing one thing on this one. Can someone tell me what that is? One design thing which is important. And no one is saying anything, so then I will say it. We are missing, since this is a food heat exchanger, what are we missing? We are missing the CIP. We need to be sure to make a CIP on it and need to be sure that the flow for this, the pressure drop for this CIP is in a respectable level compared to what this heat exchanger is doing. To do a CIP, you need to be on the solution. Then you go to setting. Sorry. Yeah, no, sorry. You need to be on the solution here in 3, and then you go to solution, not setting, solution, and then define CIP. Press this one. Then you come into this screen. Here you always need to have water. Then I always fill in 85 degrees, which is the normal temperature for the soda, for the natrium hot oxide. Sorry, so natrium, yeah, you know, from the soda, from the lye. That is the normal temperature, the 85 degrees, and for the acids, we are down on 60 to 65. So I always put in 85 here in temperature. Note that this field is bold, so you have to fill in something here. Then you have to decide which of the 2 streams do we need to CIP. Obviously, we need to do CIP on milk side. So you put a mark here and press enter. If it looks like this with minimum pressure drop, that you know we set that up in options. That was default. Keep that as it is. Then you press enter. Then it draws a stream down here in this small picture where the CIP is going to take place. And that's where the milk is running. Then it calculates the theoretically needed CIP flow for this heat exchanger and for this type of duty. And you see, we had 10,000 liter product flow, and the calculation comes up with 9,966 liters. So we are perfect. We are close to the feeding pump. We actually also get above 1.5 meter per second, which is needed doing CRP. Some actually says 2 meters, depending on customers, that they want 2 meter per second in the fittings. But in this case, we would accept the 1.5. Or we could decide this ourselves to get this up to 2 meter, if it was a requirement from the customer. Actually, I believe that none always requires minimum 2 meter per second doing CIP. So how can we change that? Yeah, we can do that by specifying the flow rate, CIP flow rate ourselves. So you click here and specify flow rate, and then we will try with 15,000 kilo. Then we got 2.3. Then we're home free, 13,000. And a pressure drop here total. And he would still be able to use the pump, because if he has a frequency converter on it, he should be able to squeeze it up to 13,000 liters per hour. Save. So doing heat exchangers, always remember to do a CIP, because it is an important thing to consider designing for food. Okay. We will take a break until 12 o'clock. I need a cup of coffee, I can feel. Okay, clear with everyone? 8 minutes break.
Yep.
Good.
Okay.